2.4, number 136. So now we have a function f of x equals magnitude of x minus 2 over x minus 2. And we want to know if there are any discontinuities and classify the type of discontinuity. So the only possible discontinuity would be happening at 2 again, because the denominator is x minus 2. So there is a possible discontinuity where the bottom would be 0. So at x equals 2. So now let's just see what's going on there. We'll take the limit as x approaches 2 of our function. Okay? Let's see what that is. Now, since our function has, let's write it like this for a brief moment. Since our function has a magnitude in it, we need to look at two different things, the approach on the left and the approach on the right. Because the magnitude function there and the absolute value function will differ whether our approach is from the left or from the right. So as x approaches 2 from the, we'll start with the left. As x approaches 2 from the left, what is our function? Well, it's this one, but I want to rid myself of the absolute value wherever possible. So as I approach 2 from the left, okay, that means I'm at values which are not quite as positive as positive 2. Right? They're below 2, like 1.999 or something like that. When I subtract 2 from that, I'm going to get a negative number. So as long as I'm approaching 2 from the left, that means the input here, the x minus 2, the total argument to the magnitude function, will be negative. If the argument is negative, we know the absolute value will negate that value. So therefore, I can replace the absolute value here with what it would do operationally, which is to negate. It would negate all of these x minus 2 values. Again, because x minus 2 here is already negative. So therefore, the absolute value would negate this already negative object to make it positive. And the bottom just stays the same. So this is how we can simplify a magnitude expression to start taking limits. Just run the limits from each side, and you're able to discard the magnitude for either a minus, a negative symbol here, or in the case we're approaching from the right, for this problem, I'm approaching from the right, and I have numbers which are bigger than 2. Numbers bigger than 2 minus 2 are certainly positive, so therefore the magnitude does nothing, and I can just leave it without anything. Okay? So it's always going to be a negation or a positive, which I don't need to write. But it will be problem dependent. You can't just say because I'm approaching from the left it's a negative, because I'm approaching from the right it's positive. It depends on what's going on inside here. You have to analyze it like I just did and think about it a little bit. Nevertheless, these factors will cancel. And so over here, it looks like we have only negative 1, a factor of negative 1 left over. So the limit, of course, of that constant, negative 1, is nothing other than itself. The limit of a constant is always itself. And over here, the constant is a positive 1. It's all that's left in here as x approaches 2 from the right. So therefore, we get positive 1. All right, so each of the one-sided limits exists, but they're different, all right? So anytime you have that situation, that's certainly a jump discontinuity. So this is discontinuous at x equals 2 because the two one-sided limits were not the same. Therefore, the overall limit here is d and e. And if the limit doesn't exist, there's no way it's continuous. Right? But because the two one-sided limits existed and were different, that implies to us a jump discontinuity.